you all have your book, and I've said it before, so you could create an account here and have access to digital copy. I will suggest you look at maybe the first few pages of the book. There will be some copying, blah, blah, blah. There'll be some information about how to access the digital copy, because you are supposed to have access to it. Okay, if you are not able to, please send an email to this address, info at blah, blah, blah. I'll try to copy that, but it's not copying. So maybe you can take note of that. Maybe you can take note of this email and write to them, okay, and find out how you could have access to the soft copy of the book. Okay. Or you can take a picture. I'll give you 1 or 2 seconds to take a picture. Okay, so, and then with that, you'll be able to make use of, so you get an account like this with a dashboard with all your books here, even if you buy the other one. I don't know, just in case you're interested. I'm not saying you have to get it, just in case you're interested. Okay, all right. Does this make sense to everybody, what I'm trying to pass across? Okay, all right, so just in case. So I thought I'd share that before we begin. So we're going to be looking at, oh no, I already opened it. So you can close this, close that. I have to make dashboard open. Yeah, I forgot to mention, it's going to be for 24 hours. If 24 months, that's for 2 years. If you order that, it's not an advert for them. It's just something I found very useful. So, for general inquiries about registration and subscription, I think this is where you have to go. Info contact base. So I copied this for you. You will need to register to access online features of the book. Visit this and register, follow the instruction. Once you register, you can activate your digital copy, use your account to make additional purchases, blah, blah, blah. To activate, can you see this, everyone? To activate your digital copy, contact them. On providing proof of purchase, your digital textbook will be activated. It's important that you keep the receipt. So I don't know how you're going to do that. You can ask them that the school bought on your behalf and have them advise what to do. Okay, so I'll send this to you. So take note of it before the end of the class. I will advise as I post the link. If you're interested in it, you'll save it somewhere. Because once the class is over, everything gets closed. So if I click on that, no. Anyway, is that info at acemathematics.com? All right, info at this domain, acemathematics, the domain here. Okay, so please take note of that. Maybe we'll try to put it here. Then info at acemathematics.com. So more like it. So take note of that. You can send them an email, then that will help. So if you have any homework, you don't have to bring the textbook home, something like that, you know. This time around that you do not have access to your book, the online book will have been more useful. Okay. And then you can activate this if you eventually decide to get it. But that is not to say that when you are given any assignment, you go to the worked example to copy the solution. Of course, you know that won't be beneficial to your knowledge, okay? It won't be beneficial to your understanding. So be careful not to abuse the material, the resources, okay? All right. So having said that, we may begin the class. So today, we'll be looking at the first chapter. Sorry, I forgot to mention. One of the things is that you have something called interactive links. So in some topics, you come across this kind of stuff, you click on it, it takes you to an application that has been designed for the purpose of learning. I'll see if I can find any of them so you can make use of them. Look at this, for example, if you click it, you see a lot of stuff, mathematical exploration, blah, blah, blah. Some of those things have been produced for learning, all right? So make use of those opportunities. Okay, so how do we go back? This is back, okay, got it. Writing proofs, blah, blah, blah. Anyways, so let's move on. So we want to discuss A and C, basically, okay? Gradients of line and so on and so forth. So we're gonna go to the board now. Confirm if you see the board. Yes, Lillian, it's called functions. And there are so many things under functions, like I shared yesterday. It's called functions. Okay, so under function, we have from 2.1 up to 2.16. Okay, so it's not just function, inverse, and all those kind of things that you and I know as function. I think I showed you guys yesterday. Maybe I'll show you again. So for functions, we'll be discussing this. Can you see my Microsoft Word documents, guys? Okay. So for functions, so these are the contents. The tools are suggested. So these are the content of functions. So for the standard level, it ends at 2.11. And for the advanced higher level, which we are, you continue up to 2.16. But they are interesting stuff, okay? And we'll be making use of technology as we treat this, okay? The goal is to be as fast as possible. It won't be like a whole term like the other one. So even if we have been able to, due to all the coronavirus thing going on around, and we have not been able to work the way we should, I think we can still be faster, even though we work online, okay? So let's see how it goes. So after I pick this, the rest will be reordered if necessary, but I'll let you know. Importantly, domain and codomain has to be done. Then these are some of these ones that you are aware of. Inverse of function, this one's not this one. So when they talk about function, they're not just talking about inverse of functions and things like that. Composite function, not just that. I think I saw it somewhere. Yeah, like this, not just this. So when they say function, there are so many things that we talk about. Anyway, so we go back to the board now. Today is 18, 11 days to the end of February. Too bad there's no school in the whole of February, the way things are going now. Anyway, there's no school, but then there is learning, right? So I want this to be a quick topic because it's something that you know. Can I ask that if anybody either has problem with or has forgotten some stuff when it comes to equation of straight line? Problems with equation of straight line. I need everybody to tell me their status on that topic from your knowledge of Form 3 and Form 4. Just, I understand equation of straight line questions. I understand gradients. I don't understand some of the stuff. Let me just have your feedback quickly while I'm writing the topic. I remember most, okay. Can I have from others, please? Please don't be shy. I just want to, I need a little recap. That's fine. I don't understand some. You can recall most. Yeah, I can recall most. I remember most too. Yeah, I forgot some, not sure which parts. Okay, that's fine. I just want to have an idea. I remember most too. Okay, I need a little recap, also a little recap. Okay, not sure. All right, so good to see that. So what we're going to do is we're going to go straight into, I don't remember some part, that's fine, Krista. So we're going to go into questions. Then we can use that as an opportunity to remember what to do. Okay. The idea is either to end everything today or to end everything on Thursday. That's the idea. You know, with practice in between. I don't want this to extend till the end of the week. So I'm going to call it equation of line, or maybe coordinate geometry. Preferably, I like the name coordinate geometry. So again, today is Tuesday, 18th. I hope you are putting dates in your book so you remember when we did what. 2019. Oh no, maybe I didn't get enough sleep, right, Callista? You were about to say that. Okay. Coordinate geometry. So we'll just review. So I'm going to say review. First thing we're going to review is the idea of gradients. As far as I'm concerned, there are about 3 ways to find the gradient of a straight line. Can you remind me of anyone you remember? Any type of question you might be given that, any form of ways to find gradient of the line based on the information given. So for example, oh, if you give me this, I can find the gradient. Oh, if you give me that, I can find the gradient of the line. So what is all the this and that you can be given to be able to find the gradient of the line? I need some response. It doesn't have to be perfect, just try to recall something. Gradient of a line. X is not a line. Yeah, thank you, Ethan. 2 points on the line. Yes, with 2 points on the line, you can find the gradient. Karen, when you say gradient, gradient is a property on the line, not on the variable. So you can't say gradient of X. X is just a variable. Okay. Coefficient. Okay, good. Coefficient of X. Yes. Yes, coefficient of X when given what? So for example, Ethan said 2 points on the line, which means when you're given 2 points on the line, you can find a gradient. So are you saying you're going to be given coefficients of X? You need to explain properly. Why? I know what you're trying to say. A nice recall. Anyone wants to put that better for Karen? Like when 2 lines are perpendicular, the product is -1. So basically you're saying, if you know the gradient of one line, you can find the gradient of the other line using perpendicularity principle. Okay, that makes it 4 ways then. I agree. Krista says, from y equals kx plus b, k is gradient. Yes. So basically, Krista and Karen are saying the same thing. What I want you to say is, given the equation of the line, you can find the gradient. Like Ethan said, given 2 points on the line, you can find the gradient. Okay. Lillian said, given another line which is perpendicular to the line or even parallel, you can find the gradient. The last one, which I'm expecting you to talk about, is given the angle between the line and the positive x-axis, or angle between the line in the direction of x-axis. You can find a gradient also. So let's put this in summary. I will exclude the idea of perpendicular lines. There's another principle under perpendicularity and parallelism. Let's say the method of gradients, 1. I need this particular. So one form of finding gradients is given the equation of the line. So given the equation of the line, you have to just make y the subject, okay? Y equals mx plus c. So m is the gradient. And what is c in this case? Anyone? Y-intercept, yes, good. Y-intercept, thank you. Not just intercept, okay? Y-intercept. And y-intercept means when x is equal to 0. At x equals to 0. So that's one way we'll recall. The second way is given 2 points on the line. Given 2 points on the line, okay? So maybe x1, y1, and x2, y2. We can find the gradients. Gradient is rate of change of y with respect to x. Change in y divided by change in x, dy dx. Anyway, that's on calculus. But here, change in y is y2 minus y1. Change in x, x2 minus x1. It could be y1 minus y2 divided by x1 minus x2. If you're starting with y2, you start with x2. If you're starting with y1, you start with x1. It doesn't matter. If you write 1 minus 7 divided by 2 minus 4, and I decide to write 7 minus 1 divided by 4 minus 2, we get the same result. Negative 6, negative 2, 3. 6, 2, 3. So if you start with 1, you must start with 1. If you start with 2, you start with 2. Okay. So the third way, if you have the gradient of the line parallel or perpendicular to it, you can find the gradient. Maybe we'll include that too. That's what Lillian was talking about. Given the gradient of another line parallel or perpendicular to it, so if they are parallel, M1 is equal to M2, and if they are perpendicular, which is what Lillian mentioned, M1 is negative reciprocal of M2. Negative reciprocal, you know what that means. You twist it, you flip it, and you negate what you used to have. This is from the fact that the product of the gradients is negative 1. The last is this. I'll show you this in a picture. So if you have your Cartesian plane, and and you have a straight line. Maybe this. Find the gradient of this line, like we said. Let's see. Okay. So to find the gradient of this line is to form that right angle triangle, right? And find this. How do we, okay, maybe I put it this way. This point has 2 points, coordinate of 2 points, right? X1, Y1. X1, Y1, X2, Y2. So which means this point is my X2, this is my X1, this line is my Y1, is it? And this will be my Y2, yes. So what that means is that the gap here is Y2 minus Y1, and the gap here is X2 minus X1. I'll put it outside. So our gradient is changing y divided by changing x. So changing y is this, that's the gap. Changing x is that. So that's how we got this one. Okay. So what we are saying this time around is this. Suppose that the line makes an angle theta with the x-axis in the positive direction of x-axis. Then you will notice that the gradient m from previous idea, which is y2 minus y1 divided by x2 minus x1, which is this divided by this, is actually the opposite divided by adjacent of that right angle triangle, which is tan of that angle. So basically the gradient is tan theta, where theta is the angle between the line and x-axis in the direction of positive x-axis. If the line is of this direction, is in the negative form, remember any line in this form has negative gradients. Let's see if that really makes sense. Again, you have your x and y plane, okay? Or maybe this time around it's not on the positive axis. So it doesn't look like it only works when we're dealing with positive axis. It doesn't have to be. So maybe we have this. Okay, so the theta in this case remains this. Change the color. This is still the theta. So it is in the direction of the positive x-axis. And remember, this theta is what type of angle? What type of angle is theta here? Obtuse. Yes, obtuse. And what do you remember about the tan of an obtuse angle? Tan of an obtuse angle is what? Come on, guys. I'm waiting for response. What is the tangent of an obtuse angle? It's always negative. Do you remember that? Yes? Good. So it's always negative. So these are the ways in which we can get gradients whenever we are solving geometry problems. These are the ways we can get gradients. So, and of course, without gradients, you cannot solve problems with equation of line. So this is why gradient is very important. It's very important for us to be able to find gradient. Okay, so I'm going to project the textbook and I need you to attempt the following problems. Can you see the book? Okay, so let's practice question 1A. 1A is easy actually, so maybe we shouldn't waste time. All right, but it's okay. 1A, 1C, and 1F. 1A, 1C, 1F. Find the gradient and y-intercepts. You can just type in the comments. M is gradient, C is the y-intercept. Use slash for fraction. So 1A, M equals this, and C equals that, something like that. Type in the comments in the chat room. And now you need to specify which question next time, okay? Oh, are you sending to? Krista, I'm just seeing your message. Krista C, is everything okay now? I'm just seeing your message on WeChat. Okay, apologies, I'm just getting it. Next time you send me a message and I do not respond, you can put it on the Zoom chat. You can click my name and send to me privately. You know, does everybody know how to send privately to anybody in the chat room? Aha, yes, like that. Yeah, that's how to do privately, Nakita. So when you send me a message about some problems, please send to me privately if you do not want to send to the class. But of course, you can send it to the class. Nothing is private. I'm not saying send your answers privately, but it's okay if you have sent it to me privately. I can see some people sending answers to me. I was talking about Krista. Krista was sending me a message earlier that she has problem hearing what I was talking about, that she needed to log out. So that's what I was commenting on. And that was over 30 minutes ago. So I'm just checking my phone to see if Leo dropped a message, and he did. Good job. I'm seeing your stuff already. Good. A and F, and which one? I think C. I think C. You're welcome. Can I ask you to take a picture of this page? Because I'm going to move to the board and write some other interesting questions. If you still need time to do this. So let's take a picture within a few seconds. I'm gonna take this, whatever you're seeing now, away and go to the board. All right, so I'm moving to the board now. So for that question on gradients, Okay, thank you, Clarissa. Then I can see your solutions. Thank you. So what if you have, find a gradient. Uh-oh. Gradient of that line. So please try this too. Join me, please. I'm sure Karen is eating as we speak. She loves food. And Brandy too. I don't trust that guy. Karen, are you sure? So if you put on your webcam now, they're not having food in front of you. And really, you see, she can't even defend herself. Kalista, thank you. I got your message. Well done. Okay, Nakita. Yeah, that makes sense. How about the other one? Actually, I said find the gradient of the line. I never said find the intercept. So when you find gradient and intercept, you're actually doing more than expected, but which is okay. It's better to do more than do less. I just wanted to clarify that. So if you write that in an exam, the C equals something part doesn't give you any point, but it's information that is welcome, but you don't get point there because it's not part of the requirement. So you might want to take note of that. I think most people are writing that. Of course, some of you just you stick to just the gradients, which is okay. So having reviewed that, let's see, we're going to be having some equation of line, because the idea here is about equation of line. Okay, I got your messages, well done. Okay, so we're going to move on now. We just mentioned that if two lines are parallel, then their gradients are equal. So I just wanted to call your attention to notation. What can you still see at the moment? The whiteboard or the book? Whiteboard, okay, thank you. So just to be clear, I want you to use this notation. Parallelism, parallel. I didn't get enough sleep, right? Basically, if two lines are parallel and they are of gradient M1 and M2, so this is the symbol, M with a subscript, M with a subscript like that. That's what I want to emphasize on, okay? If two lines are parallel, I just wanted to write this properly, and they are line L1 and L2. Let's put it that way. So this is line L1, this is line L2. The gradient of L1 is M1, the gradient of L2 is M2, then M1 must be equal to M2. We mentioned that earlier. Now, if these two lines are perpendicular, so this is L1 and this is L2, with the gradient M1 and gradient M2 respectively, then we know that the product of their gradients is -1. That is, one of the gradients is the negative of the reciprocal of the other one. So which means in this case, in the second case, if the gradient of L1 is 2, the gradient of L2 will be -1/2. If the gradient of L1 is -3/5, the gradient of L2 will be +5/3. So you change the sign and flip it. Change the sign and flip it. That's the idea. Okay, you don't have to go through M1 times M2, make M1 the subject of the formula. Just write, since M1 is this, then M2 is that. That's all. Okay, so the clue here is change the sign and flip it. Clue. Change the sign and flip it. Okay, that's the clue there. Change the sign and flip it. Okay, Vena, I got your 45 degrees. That's correct. Are you sure? Wait, 45 degrees? Because from here, yes, it's 45 degrees because M is equal to 1. 315? No. The angle is never up to more than, what are you saying? So is either your line is this way or your line is this way. If your line is this way, this is the angle. If your line is this way, this is the angle. It's either accused or obtuse. 90? No way. Where do you get 90 from? Calista didn't get enough sleep. Calculator will be lying. Why would you rely on the calculator? Okay, maybe we should address question 2. The calculator can be useless sometimes. I don't trust that dude. Anyway, so for question 2, some of you got it. So what I expect you to do is make y the subject. So from x minus y equals to 4. So x minus 4 equals to y. Because y is negative, I took it away. So I don't have to stress myself too much. So from here, m is equal to 1. And you're aware that tan theta equals to m. So which means tan theta is equal to 1. And theta will be arctan of 1. And that's 45 degrees. Okay, so that's how we get the 45 degrees. If this was -1, then this will have been arctan of -1. That would have been 135. Venus, the calculator will be lying to me if it isn't 45. Calculator isn't lying to you at this point. All right. Does this make sense to everyone? Okay, so I want us to review the following problems. Like I said, these are things that you have done in the past. So we are not going to waste too much time on them. So I want us to review. Can you still see the whiteboard or the book? No what? You can see me. Oh, okay. Yeah, it's good you can see me. Okay, now what do you see? Okay, the board. Okay, so look at this now. Let's see. Let's just review some questions. All right. So we have reviewed some of this. Gradient, blah, blah, and the gradient, that's the equation of line. Okay, maybe before equation of line, there's some interesting question we should look at here. Look at question 15. Determine whether these points are on that line. So can I ask you to do 15? Where is the chat room now? So attempt to the following. I'm putting it in the chat room for everybody. A and C. Let me begin. 16, A and C also. 17 and 16 are similar, so I don't know why. There's a difference. Let's say 17A and C. Okay, you keep that. I will use the add copy to check for the next question. If anybody needs clarification, please let me know that. Is everything okay? What is it? So where are we now, guys? 16C, 17. Okay, good. 16A, very good. All right. Let's work as fast as we could and compare notes later. So when you're done with everything, just write done. Next, we will review equation of line. Getting your work, thank you. You can also send it to the group chat if you want, or you can just take a picture of your book and send it to me on WeChat. Okay, either way is accepted. Done, Crystal. Got it. Done, Lillian, the two crystals. Crystal K and Crystal C. Crystal K and Crystal C. La 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 la. All right. More work received. Thank you. I'll have a look properly later, but I'm checking for errors if I'm not able to check your work properly, but you are confused about something, let me know. But I haven't seen any form of error anyways. Vienna, what do you mean by x equals 8, which implies t equals 8? Let me try to see what question is that. That should be 16C, yeah? Miss V, are you there? Hi, okay. So you wrote x equals 8, t equals 8. I would rather you just substitute right from the beginning. Not t equals x. It's actually x equals t. So you substitute y as 4 and x as t. So you solve the equation in terms of t right from the beginning. Not solving for x and now say t is equal to 8. All right? Just adjust that next time. Thank you. Others are sending in their work. Very nice shadow in your picture. Karen, you still manage spaces. Oh my goodness. You know, I have to zoom. After I zoom in, I have to like strain my eyes to see what you write sometimes, just because you are trying to, I don't know, be economical about your space. Ah, and then you block the whole picture with shadow. So because this isn't a selfie, you couldn't take a proper picture. All right, so OCD++, got your work. Clary, got your work. Yeah, Clarissa also did x equals 8, so t is equal to 8. I think I need to correct that presentation. Okay. Mr. Chang, got your work. Well done, sir. Okay. All right, so this is my only observation. Everybody come with me to the board. So take, for example, the question with t, that's 18. So question 18 is that 16C. So 16C looks like this. So you have find t, given that t4 lies on that equation, on that line. The equation of the line is y equals 2/3 of x minus 4/3. And you're told that t, 4, this point is on the line. If this point is on the line, it means when x is t, y is 4 is on the line. That's all you have to do. So when x is t, y is 4. So 4 equals 2/3 of t minus 4/3. This is what I expect. And this is what you solve to get your t. Okay, it's messy. So if you multiply all through by 3, I'm going to get 12, 2t minus 4. So 16 equals 2t, which implies t equals 8. What I've seen some of you do is y equals 2/3 of x minus 4/3. So this is what I said I'm not really okay with. So you substitute your 4, then you have 2/3x minus 4/3. Eventually, you got x equals 8, and you said now t equals 8. Instead of allocating x for t, why not just do it from the beginning? Because that is the basis of this point. Okay, what this means is that x equals t when y equals 4. So that's the first information you need to use. Okay? The answer is right. It's just a presentation that I'm not so impressed with. Okay, so please take note of that, everyone. So let's go further in our review. You know, it's very likely we complete this review today because these are not things that are difficult for most of you. The equation of lines, the concept of equation of lines. So let's discuss different ways in which we can get equation of a straight line and what are the information that you need to be provided with to be able to get equation of line. Before I write that, I need you to tell me what you remember. about the different ways to get equation of a straight line and the information needed in each of the cases. All right, anyone who wants to go first? Equation of straight line. Yes, I'm waiting, guys. Waiting for a response. What are the different ways to get equation of a straight line? And in each of these cases, what are the information you need to be provided with? You can speak to the mic instead of writing too many stories to explain. If nobody explains, then I call on somebody myself. Preferably speak to the mic to give me your answers. Come on. We're almost done. So with given 2 points, we can find gradient and substitute. You actually mix two things together there. One is given 2 points, you can find equation of a line. One is given the gradient and intercept. Okay, given 2 points. Okay, that's still given 2 points. Okay. You're actually giving us the solution already. I just want to know which points. So one, let's write that. 2-point form. I'll let you finish. Okay, so gradient, intercept form. As the name implies, you need to know the gradient and the intercept. The gradient intercept form is y equals mx plus c, which means if you know the gradient of the line and you know the y-intercept of the line, you can get the gradient equation of the line. This is called the gradient intercept form. Does that make sense, everyone? Okay. You can also get gradient point form, which means if you have the gradient and any point on the line, okay, gradient point means gradient and any point on the line. So basically this is given gradient m and y-intercept c, okay? In this case, given the gradient m and points x1, y1 on the line. In this case, the equation is y minus y1 equals mx minus x1. It actually looks like this, from m equals y2 minus y1 divided by x2 minus x1. Okay, so assuming these x and y are arbitrary points with no specific, then you cross multiply, you get something like that. Is that understood? Okay. So that's another point. Gradient point form. As the name implies, gradient and one point. Okay. 3. Maybe I'll try this. Another is 2-point form. 2-point form means even 2 points, basically, on the line. Even 2 points, x1, y1, and x2, y2 on the line. Actually, you can substitute directly here. Remember, your y is your m is y2 minus y1 divided by x2 minus x1. If you substitute directly here, you can have y minus y1, y2 minus y1, x2 minus x1, x minus x1. You can have this. You can have this. You can substitute directly like that. Or you could do another way. Given those 2 points, find the gradient. If you find the gradient, then substitute. Even Lillian mentioned the intercept. You can use what Lillian said. You find the gradient, then try to find the y-intercept. Okay, and substitute. So you can substitute directly if you remember this. Okay, even 2 points, you can have that. The last one is called a double intercept form. If you have the 2 intercepts, double intercept form. Maybe I'll write it here. Double intercept form. This is not tricky. Let's look at this picture. You have your x and y axis, and you have your line like that. And this line, the x-intercept is A, while the y-intercept is B, which means it crosses x-axis at A and y-axis at B. So basically, 2 points has been given. So we can find the gradient. The point here is actually going to be what exactly? Instead of A and B, maybe I write it better. So if y is B, x must be 0. And if x is A here, y must be 0. Yeah. So you can either use this method because we can find the gradient, or this method because you can find the gradient and there's the y-intercept. You can use this method also because you can find the gradient and you can use any point on the line. You can either use this point or this point, it doesn't matter, you get the same thing. Or you can use 2-point form because these are 2 points. Do you guys understand what I'm saying? Yes? Okay, good. So, so it doesn't matter which one we use, so I'm just going to stick to maybe one of them. So let's find the gradient. Can you go over 3? I really don't get it. Okay, so this is what I mean in 3. For 2-point form, I started with this from y1 minus y minus y1 m into x minus x1. Do you understand this? From 2. Okay, good. What is your m? Your m is this. Got it? That's your m. Just substitute. M from 2. Yeah, it's just, yeah. So it's just 1 and 2. No, not 1 and 2. This doesn't have intercept. It's just the definition of gradient put together in 2. That's it. Not 1 and 2, because 1 has nothing to do with, 1 has to do with intercept, y-intercept. Understood? Please confirm. One, what I mean by one, or what I understand by you saying one, is the one above, question one, the first type. The first type has to do with gradient and intercepts. The next two have nothing to do with intercept, so one does not come into play here. What we have put together is the meaning of gradients, which is changing y divided by changing x, and substituting in 2. So it has nothing to do with 1. That's my point. Got it? Okay. And like I said, you don't have to use this formula directly. Lillian said something earlier. If you have 2 points, we find the gradient, then we can solve for C and substitute back. Yes, that's also welcome. I've seen students use it even in lower grades for me. That's welcome as well. So for this, if we find the gradients, if I make this y2 and x2, y1 and x1, my gradients will be b minus 0 divided by 0 minus a, which will be what? B negative b over a. Yes? Negative b over a. All right. So if we have that, I can make use of any of these 2 points. So maybe I use this method, or I could use this. My y-intercept is known to be b. So y equals mx plus c becomes y equals minus b over ax plus c. What that means, no, plus b now. What that means is ay equals negative bx plus ab. Is that understood? Talk to me, guys. Okay, so I'm going to rearrange properly. So that is going to be bx plus ay equals ab. Remember what we did in Cartesian coordinate form. Remember this stuff, x squared plus y squared equals 9. We always try to make sure there is 1 on that side. So I'm going to do something similar. So I'm going to divide through by AB. If I divide through by AB, if I divide this by AB, I have x over A, y over B equals 1. If I divide by AB. What you have is the double intercept form. It means if you have 2 intercepts, x has intercept, x-intercept is A, y-intercept is B, the equation of the line will be x divided by x-intercept, y divided by y-intercept added together equals 1. That is another way to find the equation of a straight line. Questions? Okay. So these are different ways. You can manipulate them differently. You can do all sorts of stuff, you know, with lines. All right. So let's see. Now, how you find your gradient is up to you and depends on the situation at hand. For example, in your own problem, your gradient might be from the tangent of the angle. Okay, it doesn't matter. Your gradient could be from 2 points that you are given on the line. Your gradient could be from the sketch of the graph that you have been given. Your gradient could be from another information about another line, parallel or perpendicular to this line. So how you find your gradient depends on so many things. But after finding the gradient of the line, how you proceed to find the equation of the line depends on this information. If you are given the intercepts, or if you are opportune to know the intercept of the line, Now I'm speaking after you have found the gradient. If you happen to know the y-intercept, you go to the first type. Okay? If you happen to know, you don't know anything about y-intercept, but in addition to the gradient, you are aware that this same line passes through another point. Then you can go through to the second point, the B part. If you have 2 points on the line, you can either use that formula directly or still use 2 or 1 by going through more calculation. Okay, but if you want to do less calculation, you can substitute directly. And if you have the 2 intercepts, even without knowing the gradients, you can just go straight to x over x-intercept, y over y-intercept equals 1 and simplify. Any questions there? So I want to take note of something, general equation of the line. So we can put equation of the line in different forms. This form and the form that's almost right here. Okay, so we're going to write it here. Forms okay, so if you have written it in this form, this is your gradient intercept form. And you can have it as ax plus by equals d. In this case, our d is the product ab, all right? Ax plus by equals d. I'm trying to avoid c, so it doesn't look like intercept, all right? This is the general equation of a line, the general form. Equation of the line. So when you solve a problem, you can either leave it as intercept form or the general form. This general form, especially if m is a fraction. Remember, it might not be ideal to leave your answer as y equals to third x minus 1. But you can leave your answer as y equals maybe negative 3x plus 1. Yes, this is right. But this, you might need to simplify further. So you can say 3y equals 2x minus 3, something like that. Okay, and if you rearrange, it looks like this one. So these are 2 different ways you can leave equation of a line, depending on what you have. Okay. Okay, so we just take some practice and that will be the end. Maybe we can do the perpendicular bisector next time, so I do not rush everything. I'll send you pictures of the pages of this book so that you can do self-practice. There will be no unnecessary homework. We just go straight to the next aspect of it. Okay, as far as this Word document of my compressed syllabus is concerned, we are done. The perpendicular bisector problems are just applications, so we wouldn't have much stuff. Okay, let's look at this problem. So I'm going to open to the book now. Page 22. Okay, I'll go back to page 22. So can you see this? Write in general form. Okay, your general form again is when you have x and y on one side and the other one on the other side, all right? And this is saying write in gradient intercept form, okay? Explain why the gradient of this line, blah, 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 is this. I think everybody can do this, so we're not gonna waste time on that. Let's look at applications of what we have just discussed. So this is find the gradient intercept form in the equation of this line. So everybody, can you look at question 2A and C? 2AB is fine. No, sorry. AD. Okay, I'm confused. There are 2 different questions. This is gradient and y-intercept. This is gradient and the line that passes through. Yeah, that's fine. A and D, everybody, A and D, okay? 2A and D. Work it out, 2A and D. Tell me what you find. You may send to my WeChats. Yes. Message down while you get more. I'm expecting some stuff from this. Let me just send you a screenshot. I'm expecting. Done. Let's take a picture of the question. If you still need more time, I'm going to move away from that page now. I believe everybody must have taken the picture. Okay. So question 2 is about gradient intercept form. Question 9 is about general form. So I need you to do 9A and D, just like 2A and D. Attempt 9A and D as well. Follow the instruction to the letter, please. Crystal, could you look at your question 2A? Gradient 3 passing through 4, 1. You didn't complete that, so why did you send it to me? But 9D is right. 2D is right, but 2A is not. The question is to find the equation of the line, which should be something y, something x, but what you have there is 1 equals 3x plus 4. So I don't know, that doesn't make sense. How is your C 4? No one told you C is 4. Okay, just simply take note of that. Akita, checking your work. Okay, not included. I saw that. So 2A Mm-hmm. So you're able to find C, good. But that's not the end. Nikita, that's not the end. You just found what? C. The answer is not to find C. The question is to find, no, both questions. The question is to find what? Find in gradient intercept form the equation of the line. The question is about the equation of the line. That particular phrase in gradient intercept form is to tell you which format your answer must be. Because remember the last thing I wrote on the board? You can either have gradient intercept form or you can have the general form. So this question is about the gradient intercept form. Yes, that's why it got mx plus c form. So your answer should look like y equals 3x plus 1, y equals 1 over 2x minus 7. That should be the form of your answer. Okay, so it has nothing to do with finding C and stopping there, all right? Checking more. Miss V, checking now. So you found your C, you put it back. Very good. Then that's good. Callista, checking your work now. Callista D, in question 2D, it's given already, y-intercept 4, that's your C. So I don't know why you had to assume x is 0, you put it back, you still got the same C is equal to 4, then you have to substitute again. In fact, I think D is like the easiest of them all. It requires just 2 lines. After identifying your M and C, the next thing should be the equation and substitution. 2 lines or 3 max. But you end up spending about 5 to 6 lines here. Okay, so we don't need all this information. Krista C. Okay, so Krista uses that gradient intercept form. That's correct. Gradient point form. Yeah, you can use that. You still get the same result. Well done. So someone used that formula directly. Clarissa, checking, you found your C, you put the answer in brackets. Why? Do you know what it means to put something in brackets? Is it that you are putting additional information, you are giving us more details? But this is the main thing we want, so I don't know why it is in the bracket. Clarissa, is the main thing, yeah, so it shouldn't be in the bracket. It's the main thing we want. Corrected, all right. Got your C, you put it back. Okay, Krista K, correct now. So that's one of the reasons I want us to practice online together, because we can correct some of this misconception and whatever. Lillian, checking out your work now. Yeah, that's good. That's good. You thought I wouldn't see. Yes, I saw it. I saw the bracket. I see everything. I can see you too. You wanted it to be an emphasis. All right, I get it. Okay. Nikita, got your correction? Yeah, very good now. Okay, so Nikita, same thing I told Callista now. Since you already have that 4 as the y-intercept, that's your C automatically. You don't have to solve for C. C is already given. Okay? There's no need to solve for it. All right. Do I have more? Mr. Chen just came in now. Are you sure C is negative 11? You want to check again, sir? Y is 1. Oh, yes, C is negative 11. Yes. Sorry, my bad. So that's that. Very good. Sorry about that. I didn't mean to. So I want to correct some kind of impression that some of us So take, for example, question 2. Question 2A. Okay. So in 2A, you have the gradient of the said line is 3, and it passes through 0.41. So this is what some of you did, which is fine. So you started with y equals mx plus c. You had your y to be 4. M is gradient start, and C is, no, Y is 1. X is 4. C is unknown, so you got your C to be negative 11. Then you substitute back 3x minus 11 from here. Because Y is Y, M is 3, because M is 3, and X is, yeah, and you got that. So you could do this, Y minus Y1, M into X minus X1. This is the gradient point form. If you have the format, okay, the gradient point method. I should have called it method. The gradient point method, okay, instead of form, I should have called this methods. All right. So these are methods. Sorry. Okay. So now y minus y1. So this is your x1 y1 equals m, which is 3, x minus 4. So y minus 1, 3x minus 12. So y equals 3x minus 12 plus 1, right? And that's how you get your 3x minus 11. So either way, you get the same thing. Okay? And the second part, which is the correction I was trying to make, you have your gradients to be negative 3 over 4. The instruction was clear. Y-intercept is 4. So that's your C equals 4. So just substitute directly. Mx plus C becomes y equals negative 3 over 4x plus 4. That's all. So many of you substituted back, and I believe you got my correction. You don't have to substitute anything. It's given, and that's it. Questions? Okay. So we'll practice. We've been able to practice this. Just one more stuff to practice. Let's see. Question 13. Let's go to practice question 13. 2 questions and we can call it a day. Let's see some problems in 11 and 13. I'm going to share the book now. Okay, I hope it's not too small. All right. So I'd like you to try 11B. What about 9D? Oh, okay. 9D. I thought that's easy. So you have your gradient point form. You can make use of that. Okay, I'm going to type the question to do. Everybody take a picture of the screen.
I didn't copy the question.
Oh, okay. Just a sec. So I'm gonna, everybody please, if you need to take a picture of this, I'm gonna go back because of Nakita. Then I'll come back once she's done with 9D question. Oh, Nakita, I'm gonna send 9D to you on WeChat now. Is that okay? So I'm sending question 9 to you on WeChat so everybody could move on with their lives and continue with this. So that's question 9 sent to you. Me too. Uh-oh. Okay, how about I send question 9 to our group chat, our chat room. Okay, everybody, question 9 sent to the group. All right. I'll send pictures of these pages. So if you need to do practice on your own, please, I would recommend that. So for class practice in the last, say, 10 to 15 minutes, I need you to attempt 11B. You're welcome. I need you to attempt 13, one on parallel, one on perpendicular in number 13. So let's say B and C. Okay. So attempt those 3 problems. So I'm taking pictures of the pages now, and you can do more self-practice. Crystal C, I got your question. 9D, can you eliminate the fractions? Okay, eliminate the fractions. Coefficients are allowed in X and Y. Crystal, can you hear me? Okay, so eliminate the fractions and put it in the form of AX plus BY. So it could be something X, something Y, or something Y, something X. It doesn't matter which one comes first, and put a number on the other side. Okay, but make sure you eliminate the fraction. Thank you. Anyway. Just fun. Okay. I'm trying to take the pictures of the page of the book without having shadow, unlike someone. I'm not going to mention names. I'm sure she's wondering, oh my God, he's talking about me. Definitely not me. Karen, I never mention names. I'm just saying, like, unlike someone who couldn't take a picture of the page of the book without having some shadows, I don't know who. All right, so all right, I'll change it, I'll rotate each picture so you don't have to turn your neck around, which is what some of you do to me. When you send me a picture, I have to turn my neck. So everything in exercise 1A, which is everything we've just reviewed now, is sent to you. You practice on your own. When we come next time, we will do the application in bisector. If I see more difficult questions later, I try to check the IB past paper to see if I can find something on this. I haven't looked through the past paper, but the online question bank that I checked, I didn't find anything on this. So maybe they are not directly a topic, but they are used like within some topics. So it's not like a standalone question. The idea must be used, must have been used in some other topic, so which is fine. So it's good to review it. And the perpendicular bisector is quite short, so I'm sure we don't need 2 hours for that next time. We might have to add some other stuff to it or just begin something else immediately next lesson. Okay? So please do this practice, and there's no homework or graded tasks, compulsory stuff. It's just for you to do practice on your own, and let me know if you have questions. Feel free to post on our general group if you need clarification from anyone. So what you're trying to do might have been done by someone, so feel free to ask questions. If you don't want to throw it to the class, please send it to me privately. I'll see what I can do. If you don't mind sharing your problems with others, please send to the group. Okay? Have you all received the pages of the book? There are 4 pictures sent. Have we? All right, good, good. Okay, yes, sir. You also check the question from yesterday. I think I did something wrong. All right, okay, see. Oh, that. I think Clarissa did something, and that's correct. Clarissa, you sent me something, right, yesterday on this problem? The question of a raised to power b, b raised to power a. Yeah, so I think that's correct. Let's see. I believe you guys remember this question from yesterday. I think it's about find a. Given that a raised to power b equals b raised to power a and b equals 9a. I think the question is to find a. So it's just substitute. You don't need logarithm. Substitute. If you substitute, so you have a to power 9a equals 9a to power a. So from this, a to power 9a to power 9a equals 9 to power a times 9, then a to power a. Okay, because if you have 3x squared, it will be 3 squared x squared, right? So we're trying to get something like this from here. So if this is 9a, a to power 9a means a to power a times a to power a in 9 places. So I can break it actually. So I can break it into a raised to power 8a times a raised to power a. That's your a raised to power 9a. Then 9 raised to power a. Okay, I need to write my 9 properly so it doesn't look like a. So I'm going to write my 9 this way, then a that way. So at this point, I can divide both sides by a to power a, and that's gone. So I have left a to power 8a, 9 to power a. And using law of indices, a raised to power mn is as a result of a to power m, then to power n, or a to power n, then to power m, either of these two. Understood so far, Mr. Cheng? Okay, so this must have been a to power 8, then to power a, then 9 to power a. So it is safe to assume that a to power 8 must be 9. Okay, then your a will be the 8 roots of 9, which you can simplify a little bit. Okay, I'll simplify that a little bit. So that is, I just put it as 3 squared to power 1 over 8, which is 3 to power 1 over 4. So the simplest form is the 4th root of 3. So your a is the 4th root of 3. Okay. Clarissa sent this yesterday in decimal form. Any questions, sir? Any question from anyone? No? All right. I'll see you guys on Thursday. Okay? Enjoy the rest of your day. Verna and Ethan Chang, I'll be contacting you tomorrow. I'm almost there with your stuff. Okay? I'll contact you latest tomorrow. That's a promise. Okay? I'm almost there. Thank you so much for your understanding, everybody. And I'll see you next class. Bye.